Welcome back. If you haven't watched video 1 for the Chapter 8 exam review, please go back. I kind of cover all the strategies that could be coming our way for factoring. I've written the cool quick version of it, the same thing right here. But if you haven't watched video 1, definitely go back and watch video number 1. So I'm going to start study guide A. Again, I've already sent you study guide A over a week ago with an answer key. Okay, so let's get started. So we have study guide A for the Chapter 8 exam. I'm going to go over the questions in order. So let's take a gander. I see this first question here. It says factor each polynomial completely. Oh, I just don't know what to do. Like if that's your, I don't know what to do. We check everyone for a GCF. Could be a letter, could be a number, could be both. What's the greatest thing that both of these guys have in common? So let's see if this is a GCF question. I see the 12 and 4 have a greatest common factor of 4. That's the largest number that I can equally divide out of both. Well, this one has 3 letters, this one has 2 letters. What's the maximum amount of letters I can equally take away from both groups? Yes, that would be 2. They both have 2 x's in common. So I'm going to factor out an x2. I'm going to put that out front, and I'm going to determine what's left. 12 divided by 4 is 3. I had 3 x's, I took 2 x's, I'm left with 1. Drop that plus sign. 4 divided by 4 is 1. You had 2 x's, I took your 2 x's. You ain't got no x's. Final answer. So this thing out front is my greatest common factor. And this is what's left over when I divide out that greatest common factor. Good job. And I can't do anything more. That's it. Let's look at the next question. Question number 2 on our study guide. Looks like a beautiful GCF question to me. So when in doubt, we look for a GCF to take out. I'm looking for the greatest number I can take out. Now a lot of kids' knee-jerk reaction is 3. Now that's a common factor, but is it the greatest common factor? That's where using your multiplication chart. I have a multiplication chart for every student, and it goes up by 20 by 20. And you can see that there is a number that's bigger than 3 that these guys have in common. Do you see it? Cool. It's 9. 9 is the greatest number that I can equally divide out of both. How many letters can I divide out of both? How many letters do they have in common? What's the greatest amount? This guy has a single x. This guy has 2. I could equally take away 1 from each group. Just 1. 9x. I'm going to put that greatest common factor out front, and I'm going to divide to see what my leftover is. 27 divided by 9 is 3. You had an x, you took your x, ain't got no x. 9 divided by 9 is 1. And you had 2 x's, you took 1 away, you have a single x left. Now, visual learners, you're going to probably make this 1 very visible, right? And if you're not a visual learner, you're probably going to be like, I'm cool with that, and that's great too. It just depends on your style, right? Sometimes I put the 1, sometimes I don't. How'd you do? Cool. You can pause this video and try question number 3 on your own, which is also a GCF question. Give it a try. Now question number 3 has a little bit of a spice factor because it doesn't have a number that I can divide out because there is no greatest common factor of 3 and 13. One, they're both prime numbers. That means they can't be broken down further except that number in 1 and that number in 1. So that's not going to really help us. So I know there's no number I can take out. Maybe they have some letters that we can take out. You have 2, you have 3. What's the greatest amount? 2. So we're going to take out 2 x's. We're going to put that up front, and we're going to determine what's left. Those cancel. You're just left with the 3 minus 13. You had 3 x's, took away 2. You got a single x. Final answer. Cool. So we just did all 3 GCF questions. GCF, looking for a letter, number, sometimes both, that we can take out from all chunks, and the greatest amount. Cool. Let's go to the next level of question. Okay, so we have question 4, the next line of questions on here. So right away, my eyes see something. Okay, right away I go, I see a binomial. First of all, I don't see a GCF. They don't have numbers or letters in common that I can take out. There is no factor of 49 that also comes out of 16. So there's no GCF. So GCF, no. Next, it's a binomial. When 2 pieces long, bicycle has 2 pieces, a binomial has 2 parts. This is a binomial. Let's check to see if it is a difference of perfect squares. Difference of perfect squares, it's a binomial. Check. It has a subtraction sign in the middle. Check. It has a perfect square number in the front and the back. 49, yes. 16, yes. An x square is literally a square. So yes, we have a difference of perfect squares. A difference of perfect squares has different signs. A difference of perfect squares has different signs. A difference of perfect squares has different signs. Cool. What 2 numbers that are the same multiply to give me that 49? 7 and 7. What 2 letters multiply to give me that x squared? X and x. And what 2 same numbers multiply to give me the 16? It's not 8. I get that wrong answer all the time. It's not 8. I think I've written that wrong answer myself. It's not 8. What is it? It's 4. So if you take off the signs, look, it's exactly the same. So that's where you decide, is it plus plus, minus minus, or mixed? A difference of perfect square always has mixed. Hey, Miss Miller, I'd prefer to put the negative first and then the positive. You do you, friend. That's cool. Yep. And the way you could check this is you could multiply it out and see if it works. Let's do one just real quick so we see. I see that the middles cancel because they're opposites. 28 minus 28. That's exactly what I have up there. And you could do a quick check. That's the beauty of this, right? You could do a quick check. Why not? So that is my answer. Now you could pause this video and try 5 and 6 on your own. You should try, right? Practice is key. If I'm doing all the learning, I think the wrong person's doing all the learning. You got to practice. So you try 5 and 6. You can pause this video and give it a whirl. Okay, welcome back. So we have question 5 here. I would suggest we look for a GCF. Doesn't have one. They don't have letters in common, and there's no factor of 5. There's no number that divides into 5 that also divides in 25 that divides into 36. So not at all. Okay, so let's take a gander. First, let's check. We've already checked for GCF. Doesn't have one. Let's check it for a difference of perfect squares. First of all, is it a binomial? 1, 2, yes, it's a binomial. Does it have a difference in the middle, aka a subtraction sign? Also yes. Does it have a perfect square in the front and the back? 25 and 36, are they on my list? Yep, and yes, they are. And by the way, this is up for the test. Reference it as much as you'd like, right in front of the students. Yes, this is in fact a difference of squares. A difference of perfect squares has different signs. A difference of perfect squares has different signs. We have 5x and 5x. Those multiply to give me that 25x squared in the front. And we have 6 times 6, which multiplies to give me that 36 in the back. And we have opposite signs so that when we did multiply it out and check our answer, the middles do in fact cancel. And yes, you're welcome to make the negative first and then the positive second. Cool. Let's try that last one. We have question number 6. First of all, let's look for a GCF. Doesn't have one. They don't have letters in common, and they don't even have numbers in common. So that's a big no. Well, I see 2 parts. Let's go over to our little binomial, 2 parts. Is it a difference of perfect squares? Let's ask ourselves. Is it a binomial? Yes. Does it have a subtraction sign in the middle, aka a difference? Correct, it does. Is it a perfect square in the front and the back? Well, x squared is definitely a perfect square. Is 64 on my list? Yes, it is. It is a perfect square. That means there are 2 same numbers that multiply to give you that. A difference of perfect squares has different signs. A difference of perfect squares has different size. So we have XX and we have 8, 8. And again, you can multiply that out real quick. You have plenty of time on the day of the test to check your answers. There is no rushing. I don't rush kids during the test. 8x's, take away 8x's. These are opposites of the same thing. They cancel. And there's my final answer. That's a quick check, yeah. It went right back to the original. Cool beans. So I'm going to stop this video here. We just finished the first 6 questions. And then video 3 is going to start with question number 7. Cool. Have a great day. Bye.